Alright, so for the first problem, we are going to review from last class. So, let's get started. So, we're going to get started by looking at these two compounds. The first one is an acid, and the second one is a base. Okay, and we're going to get started by writing the dissociation reactions for both. So, let's start with H2SO4. Alright, I'm going to give you guys 1 minute. Shouldn't be too difficult. This is what we went over last time, to write the dissociation reaction for H2SO4. So if you forgot what that looks like, look back at your notes from last class. What do acids do? And see if you can write the dissociation reaction. I'll give you a minute. Acids, they release or give up a hydrogen, right? So if this is an acid, that means it's going to break off one hydrogen. And if you guys remember, H is +1. And so the remaining part of the molecule will be the same thing, just take away an H. So there's two H's, so it'll be 1H, SO4. And if you give away a positive ion, you become negative. Okay, so that's the first dissociation for the acid.
How do you know it's an acid?
It has H's. Alright, now, some of you guys might have noticed that this acid has two hydrogens, right? So that means there's going to be a second dissociation. We talked about that last time as well. So we're going to take this remaining compound. This is also an acid. And this can also release its own hydrogen. So HSO4 minus can give up its hydrogen. If you take away a hydrogen from this molecule, you're left with SO4. And it goes from -1 to -2. And so these are the two acid dissociation reactions for this acid. Okay, again, acids, they give away a hydrogen. So our base in this question is going to be RbOH, and we know that it's a base because it has me inside of it, right? It has OH. So bases are like you guys. You want to get rid of Mr. O. You want to get rid of OH. So these guys are going to separate from OH. You want to get rid of me. You want to go on to better and things. All right, OH minus, and if you give away something that's negative, it becomes positive. So this is the dissociation reaction for a base. You get rid of Mr. O, and whatever's left over becomes positive, just like how you'll be happy when you're finally done with this class. So this is what was on your quiz for neutralization. You're going to take your acid and your base, and they're going to combine together. So every neutralization reaction is an acid. So in our case, H2SO4 plus a base, which is RbOH. Okay, and the acid and base are going to react, and you're always going to make the same two compounds. The first compound that you make is water. So one of the hydrogens from your acid and one of the OHs are going to combine to make H2O or HOH. So you're going to make water. Oops. Okay, so that's the first chemical that's made when an acid and base react together. Okay, the second chemical that's made, we call that a salt. And the salt is made from the leftovers of the acid and the base. So we're going to get to how to do that in a sec, because this is the real skill of neutralization reactions, is figuring out what the salt is. But before we go into that, any questions on the general setup for this equation? We're not at the salt yet, so if you have questions about the salt, hold off for now, but yeah.
For the H2, does it matter if it was just HSO4 or H2SO4?
It's going to matter in just a second with the salt and the balancing.
But for the HOH part, would that change?
No, water is always HOH, so that always stays the same.
So is there still an extra H?
Yeah, there's going to be an extra H, exactly, yeah. We'll get to that. Good eye on that. Okay. So, in order to make the salt, we need to figure out what ions these two things break up into. So, let's start with the acid. We know that the acid releases hydrogen, right? So, there's going to be two hydrogens that it gives up, and SO4. Okay, and we need to figure out what the charge on SO4 is. So, if you guys take a look, SO4 is balancing out two hydrogens, which add up to +2, right? So what does SO4 have to be to balance this out? Negative, or 2 negative, so 2 minus. Okay, so that's how you can figure out the electrical charge of the anion. All right, for the cation, this is going to release Rb and OH, And we know that OH is always -1. So what does RB have to be to balance out the OH? Positive 1. Yeah, positive 1. Yeah. Yes. All right, so from there, we can kind of see what we need to do. If you guys take a look, the H and the OH, we said react, right? So these two are going to make water. This is where we get the HOH. And we have an extra hydrogen hanging out by itself, right? So in order to balance that out, we have to add another RbOH. So Rb plus and OH minus. Thank you. Appreciate that. Okay. And so what's going to happen is this hydrogen is going to react with this OH. And if you guys take a look, how many waters are we going to make then? 2. So we put a 2 in front right here. That's how we know how many waters we make. All right, lastly, we need to figure out our salt. And the reason why we did this in the beginning is to balance our equation, and it works out here as well. Because if you take a look, RB is +1, right? So we're going to need 2 RBs in order to balance out the SO4, because SO4 is -2. So +1 and +1 balance out the -2, which means the salt that we make will be Rb2SO4. Okay, so that's the real skill of these neutralization reactions. You want to get very comfortable figuring out what salt you're going to make, because the acid, base, and water is pretty easy. It's always the acid plus the base, and then this right here. And then don't forget the 2 right here, because we added another RbOH. Is that what you're going to ask me? Yeah. Thanks for pointing that out. All right, so today we're going to be learning about something called pH. You guys might have heard about this in your other science classes before in the past, but I want you guys to write down what pH is. pH is a measurement used to describe how acidic or basic it shouldn't be compound, it should be solution. Okay, a solution is. Okay, so pH is basically how we measure, hey, is something, how acidic is something or how basic is something?
Wait,
Just copy this down. Yes.
this may be a stupid question.
No, you're good.
Does it?
So if we take a look at this chart, we got some examples, like battery acid has a pH that, and the number is 0. Vinegar has a pH of 3, coffee is 5, so on and so forth, right? So different substances, different solutions have different acid and base levels. Now, I'm going to show you, I'm going to have you guys copy this down as a little, I guess, chart to get some information about pH. So I'm going to have you guys draw a little number line like this. Okay, we're going to be writing on it, so don't make it fill up like the whole page, but leave enough space to write on it a little bit. Okay, and let's call this the pH number line, okay? Okay, now, the middle of pH, the place, I guess the most important spot on the pH number line is going to be 7. Okay, if something has a pH of 7, it means that it is neutral. This is where pure water is. So, just water, just H2O, just HOH will have a pH of 7, okay? Any number less than 7, if something has a pH less than 7, it means that it's going to be an acid. And anything that has a pH with a number bigger than 7 is going to be a base. Okay? So again, pH 7 is the middle point. It's the neutral point. That's where water is. Anything less than 7 is an acid. Anything greater than 7 is going to be a base. Okay? And if something is an acid, it means that it has more H+. Okay, and if something is a base, it means that it has more OH-. Okay, so this little number line kind of summarizes all the information that we have right here. Is any number less than 7 for a pH is going to be an acid. Okay, so that includes numbers like 5, 1, but it can also be a number like 0, and even negative numbers like -2. If something has a pH of -2, that means it's really, really acidic. Okay, so you can have negative acidity.
Like,
yeah.
What's that acid on sour candy?
No, that's not going to be anything close to that. The ones that have negative pHs are like superacids. We're not going to talk about that in that class.
Right there.
So to calculate the pH of a solution, it's pretty simple. I want you guys to copy down this equation. I know it looks very scary. All right, so pH, we said, is a measurement of acidity or basicity. And then if you guys take a look, there's a negative, right? So always include the negative sign. People always forget this and their numbers come out wrong, so just keep that in mind. It's negative, and then log. And if you guys remember, if you have log 10 on your calculator, that's the same thing. Okay, so pH is negative log, and this right here, just in the brackets, this means concentration, okay, of H+. Okay, and concentration, if you guys remember, is molarity. So we're going back to molarity now. I know, traumatizing, isn't it? Okay, so pH is the negative log of the molarity of H+.
That says cotton.
Alright, so for number 2, we are solving for pH. So I want you guys on your paper to write number 2. And we're going to copy down the equation. pH is the negative log of H+. Okay, so we're going to be solving for pH. And I know this equation looks really scary because of the log, but it's very easy to plug it in. It says the solution has an H+ concentration of 0.8 molarity. So, just plug it in, yeah. So on your calculator, you're going to do negative log of 0.8. Okay? And you just punch it in. Now, depending on what type of calculator you're using, your phone and whatnot, you might need to punch it in a little bit differently. I don't know how everyone's calculator works, so I can try to help you out. But see if you guys can punch this into your calculator and then get your final answer. I'll give you guys a final answer in just a second, just to make sure you're punching it in correctly. So, but try punching this into a calculator. Again, don't forget the negative sign. And again, log 10 is fine, but negative log of 0.8. Alright guys, so let's see if you guys got the answer that you should get. So depending on your calculator, sometimes you put log first, sometimes you put the number first. My calculator up here, you put the number and then log. And you see how you get a negative number, right? But you need to negative it. So your answer should be something around 0.097, around there. If you got 0.096, that's fine, but you need a number pretty close to this one right here. That's fine. Okay, as long as you're close. If you got something way off, you punch it in your calculator wrong, and I can help you with the punching into the calculator. It's just different for everybody's calculator. But again, don't forget the negative sign. And again, log 10 works. But something around 0.09, 0.097, 96, whatever. Yeah.
So everything gonna be negative.
If you take a look at number 3, we're still looking for pH. But this time, I'm not giving you molarity, right? If you take a look, we have 500 milliliters solution, and it contains 0.05 moles of H+. So to solve this, we first need to find molarity. And if you guys remember, molarity is moles divided by liters. Okay, so we're bringing back stuff from last unit. Okay, so first you need to find molarity by using the molarity equation. Okay, so I'm going to give you guys about 3 minutes. See if you guys can solve this from beginning to end. You can work with the person next to you. Again, you need to use these numbers in the molarity equation before you can find pH. So we're going to take the moles of H+, plug it into the top of the fraction on the molarity equation, divided by the milliliters, which is 0.5 liters, because we divide by 1,000. If you plug that into your calculator, and some of you guys probably don't even need to, but 0.05 divided by 0.5, that's going to give you 0.1. Okay, so that's your molarity of H+. Alright, now that we have molarity of H+, we can plug it into the pH equation. So for pH, it's going to be pH is negative log of 0.1. So we're going to go on our calculator, and that's going to give you an answer of 1. Okay. Should be 1. Okay, so for number 5, we're going to just write down our equation. pH is the negative log of H+. And I'm going to go through all of the math steps up here, just so you guys can see how to solve this problem.
We skipped 4, right?
Yes. Alright, so if you guys take a look, we are looking for this right here. We're looking for H+, and we are given pH. So if you guys take a look, pH is 4.52. So we're going to write down 4.52. Okay, and 4.52 is going to equal to the negative log of H+. This is what we're looking for.
We're not doing number 4 so.
Nah. Alright, so now we need to solve for h plus. And so what we have to do is we need to isolate h plus. Now I'm going to show you guys how to do that. The first thing you want to do is you want to move the negative to the other side. So we're going to move the negative to the other side. Yeah, so it's going to be negative 4.52 equals log of h plus. Okay, you're flipping it by switching the other side to negative and this side to positive. Okay, so far so good, guys?
Oh,
Okay.
wait.
Hey, according to Nico, it's the KCP.
So, we need to get rid of this log right here. Okay, and I'm going to show you guys how to get rid of the log. Okay, so the way that you get rid of the log is you take both sides. So you know how if you do one thing to one side of the equation, you have to do the same thing to the other side. Okay, the way that you get rid of log is pretty simple. You just take what's on each side of the equation and you put it over 10. So you're going to do 10 to the power of negative 4.52. So it's an exponent. And then 10 to the power of log h plus. Okay?
Oh, and since log
Yeah.
10, it gets canceled.
Exactly. And so since it's log 10, this cancels out. And the right side becomes h plus. And the left side, you just need to plug in 10 to the power of negative 4.52. Okay? It's just math. Just know that if you have 10 to the power of log, it cancels out. And the h plus comes down. So depending on your calculator, you can get three different answers that come out of your calculator. Okay, so the first one, if your h plus value, if it says underflow, okay, some people might get that. It means you need to borrow a calculator because that means that your calculator doesn't like really small numbers, so you're going to need to borrow a different calculator. Okay, you might get this answer right here. You might get something like 3.01. And then you might get an E, negative 5. Did anyone get something with the E? No E's? Okay, that's fine. So the other answer that you guys might get is 0 point and then 4 zeros, 301. Did you guys get this instead?
Yeah.
Yes, okay.
Oh, I got 3 too.
Same thing, close enough.
302.
Yeah, 301, 302, whatever.
We have to put all those zeros.
Yes, 4 zeros. So those are the three options. Okay. So if you guys take a look, these numbers are this number is very, very small, right? And so in science, since we work with either really big numbers or really small numbers sometimes, we have to use a method of writing our numbers called scientific notation. I want you guys to write this down. Scientific notation. Okay, so scientific notation. And scientific notation is basically a way of writing, so let's write down the definition. It's a way of writing very big or small numbers. Okay, in this unit, it's going to be very small numbers. So like, if you take a look at this, it's 0.00003. Okay, and we're going to get numbers that are even smaller than that later. So we're going to use something called scientific notation in order to work with these numbers. All right, guys, so the number that we have right here, this value right here, is going to be, let's think of this as our regular number, okay? So this is written in a way that kind of makes sense to us, right? This is our regular number, but it's just really small, but this is our regular number. I'm going to show you guys how to turn this into scientific notation, and it's very easy. We have to move the decimal until it's behind the first non-zero number. So if you take a look, the first non-zero number is 3. So we're going to move the decimal until it's behind 3. So we're going to count. So we're going to go 1, 2, 3, 4, 5. So if you take a look, we move the decimal 5 times to the right. So far, so good? So that we can write it in scientific notation. So what we're going to do is we're going to take the number 3. The decimal is now behind 3, so 3.01 or 2, depending what's on your calculator. And then we write times 10 to the power of negative, however many times we move it, negative 5. Okay, so this is the scientific notation way of writing the number. Okay, and you need to be comfortable turning regular numbers into scientific notations and vice versa, because I might give it to you either way. Okay?
I can call it the SN.
Yeah, if you want to call it the SN way, that's totally fine. I'll understand what it means.
Oh, damn.
So for scientific notation practice, we're going to practice with 2 numbers. Okay, and I'm gonna show you guys how to do the first one, and then I'll have you guys try the next one. But again, don't freak out. It's the same thing that we've been doing.
Definitely don't freak out.
All right, so let's move the decimal. Okay, so we're gonna move the decimal, and we're gonna count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved it 11 times.
10 to the power of
Yeah.
negative
So 8.5 times 10 to the power of negative 11. Okay, so we're gonna move the decimal 1, 2, 3, 4, 5, 6, 7 times. Okay, so that's gonna be 1.05 times 10 to the negative 7, or 1.05 e negative 7.
Bro, it's always one more than.
I have the answer, all the steps for you guys. When you guys are solving this on your own, you guys don't need to write all these steps. Just give me a couple of the steps where you plug in your numbers. I just put it here so you guys know what happens every step. One thing I do want to mention though, you are looking for concentration, right? So you need to label your number as molarity. So just keep that in mind. If you guys didn't do that, label your number molarity. All right, let's do the last type of problem. We're going to do this one together, step by step, and then we're all done. All right, so in this problem, we're talking about your stomach acid. So a typical human stomach, so if you guys look down and look at your stomach, there are about 80 milliliters of stomach acid in there to digest your food. Not a lot. Stomach acid has a pH of 1. Okay, and we are looking this time for moles of H+. Now, if you guys notice, this is different from the previous question where we were looking for molarity. This time we're looking for moles, and I'll show you guys how to find that. The first step is pretty simple. Okay, you are going to just use this pH formula and do the same thing that we just did. So I'm going to give you guys 2 minutes. I want you guys to find the molarity of H+ using the same method we learned earlier. Okay, so do that. Take 2 minutes, and I'll show you guys how to finish the problem from there. All right, so once you get the concentration, again, this is 0.1 molarity. All right? Now, if you guys remember from earlier and from last unit, molarity is moles over liters. We are looking for moles. That means we're looking for the top of the fraction. So we're going to plug in 0.1 into molarity equals, we are looking for moles divided by the liters, which comes from 80 milliliters. We divide that by 1,000. That's 0.08 liters. So to solve, very simple, just multiply both sides by 0.08. These cancel out. And so we finally get moles if you punch that into your calculator, and we are done after that. Okay, it'll be 0.008 moles of H+.
So, how do you get to